Hello everyone. In this video, I would like to discuss about Orchastic system on Kubernetes. Uh, Here's my video agenda. We will talk about microservice, briefly discuss a short version about microservice based on a typical business flow. We will discuss about traditional development and its problem with modern system. To solve this problem, we need microservice design. And then with a microservice system, we discussed about Kubernetes deployment, how to deploy a system on Kubernetes to solve the problem that traditional deployment problem facing. And the last session, I will show you the demos, how the Kubernetes system working. That how to deploy, how to scaling, and showing the resilient features. Okay, let's start. And here, typical business flow that client send request to server processing and dispatch to business domain. The machine do business logic and return to the controller. Meanwhile, send uh, to log on the domain system like log, staging, notification, etc. And this is traditional development that we place in own in single application on a server that process request and return. With this the deployment model, we got problem with the system, modern system that need to handle big amount of requests. Let's imagine we need to handle thousands of requests per second that need to have respond in just 1 second. So this database system, this to support this we need database system. We also need a feature that resilient system need to run 24/7. That is something wrong, and we need all the back up to keep system working, and we need the restart from failures, and we need elastic feature that the system may to scale up to handle big amount of requests in the rush hour, something like in Black Friday, but in regular, with just smaller resource to handle those handle requests. And with traditional development, it's difficult to support reactive features because why? We have something like log balancing, web farms, but it's difficult and expensive to support it. So with microservice design, how we split the system to multiple smaller parts. The client send request to API server or web server, and web server just process prevention and play message to an message middleware, something like Kafka, RabbitMQ, and we have multiple processors get message from middleware to processing it, and probably send the result direct to web server or play to Kafka. Also, processor will send message for other domain to process subtasks like notification, staging, etc. With the design, we can scale up several parts of application. For example, for API server, it just handles simple tasks, so we can hand the single node with a little high resource, but not expensive. For processors, we can scale multiple unit, probably in multiple machines, so it's independent each other. Can to thousand to hundred or something like that to handle big amount of requests. And this one is handle less important tasks, so just some. So we can uh, scale up sep, uh, uh, a separate part of system. Uh, now we have a microservice, so we will deploy in the servers. Where traditional deployment that we have a lot of applications unit here, web API unit, multiple middleware and unit, multiple for system unit, multiple other domain like state, notification, probably multiple database. So DevOps will specify and decide target server which one will host which unit from the database here, state here, uh, processor here and here and here. Yes, they will have to decide by uh, DevOps. DevOps do it by script or manually. And when the system is scale up, for example, we need to add more processors, DevOps do it manually again. Or something fail, we need to set up something up to replace, DevOps do it manually again. Backup or update, so, it's a really big task. Many work. That's many and risk because do it and configuration manually. And to solve no problem, Kubernetes was born. Yeah, therefore work with uh, application unit and write metadata and send to Kubernetes. Kubernetes will own the server work under Kubernetes as a single system. So therefore see this one a single system, not a multiple server, single system. And to design which application unit on which server Kubernetes do it. Clone, scale, scope or scale down Kubernetes unit. For example, if we need more processors, therefore specify metadata and Kubernetes will choose the target server and add more process thread. So it is much simpler for that. To have a better understanding of Kubernetes, we will discuss some basic concepts. For pod, pods mean that one application unit on Kubernetes. For example, we need one application unit for API, one application unit for middleware, message, one application unit for processor, one application for staging, logging, and one application for database. And if we scale up multiple for the scale up multiple processors, so we need multiple pods for processors. Uh, Pods not a single process, but we can simplify understand pod as single process. Service endpoint. So imagine in a system that have multiple process and this one need to contact each other. So for example, the API need to contact the Kafka and processors need to contact Kafka. So we need to define the endpoint for Kafka, something like DNS. So then this application need know where to point to contact the target unit. For example, database we also need an service so all the unit can contact it. Deployment and stateful. Deployment stateful is to control how application is scale up, scale down, how to set up. Deployment means that every pod in deployment is same, is equal. Every pod can handle request uh, to that deployment. For example, we have deployment for app processors and uh, deployment that have multiple ports. So each port in deployment can hand request to that deployment. In concept, statefulness also control how application unit cloning, but only one port in service can handle request to that application unit. For example, we have Kafka and deploy at stateful service. So only one port of Kafka will handle request. Or we have Mongo DB deploy at stateful service. So only one port of the will handle request to MongoDB application unit. We'll talk about this mounting, volume mounting. Volume mounting means when application unit need to store data, we need to mount. For example, database will be mapped to will deploy to this port, and when this port fail, so all the port might on the port up to replace, but with data mount data this that this new port can save on data, so data mount for keep data not losing from port failure. For example, we need data mount for Kafka, for Zookeeper, and for MongoDB. Okay, now I will show you the system Kubernetes system working. And demo is on a single Docker desktop with single node Kubernetes because Kubernetes node work under Kubernetes as single system. So with single node or multiple node, it work in almost same uh, to all the outside because well, people see Kubernetes don't work directly with nodes, work whole system. So how many nodes inside is not equal to uh, uh, develop, but to have better performance, we need multiple server inside. I will let's say Docker desktop with Kubernetes enable, so we can work on it. Okay, here is metadata to to deploy application unit on uh, Kubernetes. We need to define metadata. For example, here we have service for web service. What is service? We already discussed it, and we have stateful web service. It's using an image that I wrote it, and this is Docker image. And we also have deployment for processors. Docker image. It's I symbol copy the artifact to Docker. This is one of the simple way to create a Docker image. We can also using existing one that for example MongoDB using the predefined image provided by Mongo, or Kafka using the image provided by Confluent. Okay, based on Docker, we build it. Also, we push it to Docker Hub, and then we apply the metadata. So Kubernetes, you create the create application unit from for first is under workload. We have processor application unit, state application unit, Mongo as stateful, Kafka as stateful, Abstinent Web Service as stateful, Zookeeper as one. All of this from this metadata. Okay, let's see how system working. To see our system, we need forward walk, so we can test it from outside of Kubernetes. if production we don't need this step because we can define the port that export from outside. But in development we need this step that port forward. So when outside here we can accept it via port AO. Okay, send request and we got response. Send request and got response. Now we should see the log file and this processes show log. Oh, show log. Okay, I'm sorry. I need to restart the Visual Code. It's sometimes lost connection. So now come back, keep going, and he has show log. Yes, we see that. This is process 4. Now try to request again, and yes, we get file. Send again. Success. Okay. Now we scale out. Scale out 0. So we don't have any processor port for processor unit anymore. Okay. Now send request. No response, and we got timeout. 20 seconds. Go back. Yes, timeout. No response. No processing. And now we start it. Add my spot for it again. Yes, it up. And send it again. Yes, we get request. Send again. Yes, request. And now to check the log for the log. Yes, we have request coming processing. Because we restart it, so under the counting request to just for showing how request coming as reset and combine come to 3. Send again, we come to 4. Yes, to 4. Similarly, state. Thus we have multiple log. That's a lot of log. Okay. Now I will demo the scale up. For example, we now 2 processor, one processor scale to 2. Okay, 2. Refresh. Yes, we have two port for processors. Yes, on up. Currently, we configure Kafka just single partitions, so only one port able to handle a request. Let's try this. We have a lot that here, so let's run. It's sending request. Yeah, send request. Now we can show log here. Follow log. This one not this one. Well, how about this one? Follow log. Yeah, this one only one processing. Only one processing. Now we will increase the partition for Kafka. So we have two of them requests. Okay, we will increase the partition because because the processor will process message from this partition, and for this topic by default is only 1%, so only one processor. Now we improve, I will add it to 2. I think we need to stop this. Oh, it stopped already. Oh, why is too long? Okay, success. So now try again and see the log. Oh, we already have it. So just open. Yeah, this one running, request coming here. How about this? Follow up, follow up. Oh, go 2, 3. Okay, let's try. Okay, let's see. Request coming. Coming. Request coming. Yeah, I think it stopped. Yeah, it stopped. Just try again. Okay, request coming. Request coming. Coming. How about this one? See that 3 processors, 3 port of processor, but only 2 of those processing requests. Why? Because we set the partition only 2. So if we set up the 3, is we have 3 of them to processing request. Okay, let's wait. Okay, now we already set to partition to 3, so we see that 3 processor handling request coming. Yes, coming. Yes, coming. Yeah, this is how system scale up and down. Stop. Double check again. Yes, coming. So 61. 62 coming. How about this? Coming. Okay, how about this? Coming. Yes, three of those handle requesting. So we can scale down. Scale to 1. Okay. You see now only one port for processors that we scale up. Okay, now I will demo the religion feature. For example, now we have one, and the port may problem. I will turn it off, turn the container. Something just a demo. If the system fail, this one, it doesn't fail. So just for example, we stop it. Yes, or the one we get up to replace this rock. Yes, immediately. And the one get up. I will show you more detail here. I think okay. Let me check it. Sure, system still rocketing. Okay, still come back. Now, for example, we uh, now we stop it. Yes, it stops, and other one up to replay it. State. Yeah, other one up replay it. That's a religion. For example, we scale to three. Oh, sorry. Scale to two. Okay. Now we delete one and other one immediately up to replay this one. Yes, delete the port. I see. Yeah, then you see the number differ. The end number differ. But for this one, just up to replay the previous one. That is resilient, and it's up, and I will show that it handling request. I think that we need to restart studio code. Oh, okay. And now try request coming. Yes, it's up and processing request. So that is uh, how scaling resilient working. Okay, thank you for watching video. I hope you got some information that's useful. See you in the next one. Bye bye.